Today's question is trapping rainwater. Basically, we are given an integer array that indicates the height of the bars, and we are required to return the units of water that is stored within these bars. The absolute naive approach that comes out to our mind is through intuition. So let's discuss what intuition this question needs. So for every unit of water stored, it is stored because of the both the bars that are present in the left as well as the right. Right. So the level of water stored in a particular bar area would be equal to minimum of either the left or the right. Right. Why? Because you can see over here, uh, the minimum of left and the right will decide the level of water for the current height. And what will it be? It will be minimum of left and right minus the height of the current level. Because as you can see, this thing, fourth bar, the water stored by the fourth bar is 1 unit of water. How it can be calculated? The left of the bar is 2 and the right of the max bar is 3. So uh, minimum of 2 and 3 is 2 and 2 minus current height 1, which is 1. So this particular 1 unit of water is stored in this form, and we need to calculate this for every bar, right? And this could lead us to big of n, because first we will calculate uh, left max for traversing once, then we will calculate right max by traversing another time, and for the third time we will calculate the current water level by minimum of left and right. Whatever the answer comes, we will simply subtract it with the current water level, and we will add it to our final answer and simply return it. This solution would seem like something like this. We will first of all calculate the left max for every uh, bar, then the right max for every bar. We will store it in two different arrays, and for the third time, this is the final time, we will be calculating what amount of water is stored in the current bar, and that would be minimum of left and right. Remember, the bar water stored in the bar would be decided by the minimum of left or right, because anything which is higher than the left or right, let's say this thing, the water will not stay, it will fall. So only the minimum will decide the level of water stored in the current bar. And for the third time, we'll find the minimum of that particular index, and we'll add it to our count, and also subtract the current height with the valid, right? Because the current height will reduce the amount of water stored. And finally, we will return the count. So this uses big O of 3n of time complexity and big O of 2n space complexity. So the interviewer will not be happy with the extra space that we are using. So he will ask us to optimize the space complexity. And here's where the idea of two pointer comes. You will notice that for every level, we only need one of the bar values. And why is that? For every level, we need either the left max or either the right max. As for every level, we are calculating the minimum of both of them. And this could help us. How this could help us? By keeping track of left max and right max. So we will simply uh, track this left max and right max by our variable. Instead of using an array, we will track this by a variable. Now, uh, previously we were calculating left max and right max by traversing the array individual times. If we want to keep track of the left max and right max in single iteration, we if we start from the left, then we will miss out on the right, and if we start from the right, we will miss out on the left. So this gives idea to us for usage of two pointers, and hence we will keep two pointers in track, left and right. Now we will iterate over the array, until left passes the right. And for every time we will check if the left height of the left bar is less than the height of the right, then we will, which means the minimum of left or right. Remember, the minimum of left or right, what we need minimum of left max and right max. And if the height of the left is less than height of the right, which means we are currently deciding on the left max, this thing. Else, if the height of the right is small and the height of the left is larger, then we will require right max, minimum of right max, and hence we'll come to the else part. So this was the intuition behind why we are using left pointers and right pointers in the single iteration. Now what happens? Let's look forward to it further in the depth. If height of left is smaller, which means we are on the left max side, we got this. And how we will calculate? If the current height, if the current height is greater than the max of left, which means there is a bigger. I'll show you. Check out this thing. If the until here the left max is 2, now the new height is arrived, that is 3. That is obviously bigger than the left max, so we will update this. Why? Up till now whatever the water was stored was due to this, and it has been accounted. Now new height appeared, which means this will be the minimum, and this will not take account the new water, so new water will not be added. So we will update the new max left, because this new updated max left will help us in to take into consideration the next iterations. Similarly for right side, if the current height of right is greater than the max height, then we will update it. And if it is smaller, which means there's something space left where the water will be accumulated, and hence we will add it to our final result. And what it will be? Max left minus the current height. That much amount of water will be accumulated there. If the current height is less than the previously tracked left max or right max, then that particular amount will be collected into that amount of water will be collected, and we will simply add it to our final result. And that's how all the logic comes into picture, and we will finally return this result. Thank you.